Good afternoon all. I'm going to finish my filter boards today. These are for the Vocoder. The first build of the Vocoder, which actually isn't going to be a Vocoder, it's going to be a spectrum analyzer. I'm going to build 12 filters. There are actually 14 here, but I'm not going to build filter 14 because it's a high pass. These are all band pass. I'm not going to build filter 1 because it's a low pass. These are all band pass. So here's the filter. It's just this stage here with the 2 op amps. And you can see that it has 4 capacitors. They're all the same value. I've marked them here as 15N, but that's for band 7, and I'm actually building band 2. So I have to look at this chart here, channel 2. I'm going to need 68N, so I'll need 4 of those. I'm going to grab those now. Now, I did say in a previous video that I thought this was a Sallen key filter, but it's not. It's actually a multiple feedback filter, and I'll explain how I know that. If you look up Sallen key topology on Wikipedia, it says that it uses a unity gain voltage amplifier with infinite input impedance, 0 output impedance. It's got a little diagram here of a generic one. Some of these components can be resistors, some can be capacitors. But there's the unity gain sort of voltage follower. And that's not what's in my filter. My filter looks like this. That's not unity gain because we've got a different resistor there to the resistor there. We've got capacitors as well. No, this is a multiple feedback filter. I know that now. So for this one, I need 68 nanofarads, and these are quite big. They're going to be a tight fit. If you look at the filter up at the high frequency end, of course, you've got very small capacitors, and they have to span, this one has to span sort of 1 gap, this spans 2. On the other side, that one hasn't got one on the other side, of course. On the other side, it has to span 2, and then the other one spans 3 strips. So I've put the capacitors in at sort of funny angles, but when I got down to this one, which is a much lower frequency, you can see that they're all starting to become a bit of a tight fit because they're physically quite large, because this is a lower frequency filter. So I'm going even lower frequency still. These are monster size. It's going to be fun trying to fit them on there. So it might actually be easier to fit the resistor that comes from the output of the first op amp to the sort of input stage of the second one. That's this resistor here. I've marked it 47K. It's resistor 3. Is it 47K in channel 2, resistor 3? No, it's not. It's 24K. And I think that's the same right up to the end on the high frequency filter, filter 13. That resistor, is that 24K? Is that red, yellow? I can't see, the lighting's not very good, but yeah, I think that's 24K. So here's the 24K resistors. I have 100 of them. I don't know how many I need. Probably not that many. Where are my cutters? Now, since this is going to be quite a lot of just me rambling while I solder components into my board, I thought I'd do a sort of mini Q&A. There might only be one question, but the answer could be quite long because the question is here from Gainster, and it's, I've been watching your videos for quite some time, and just out of curiosity, I was wondering what you did for a living. Well, I'm glad you said did, because now I kind of do YouTube for a living, but prior to that, I did various things. I said it was going to be a long answer, so I'll start right at the beginning in about 1982, I think it was. 24K, red, yellow, black, red. That's 24K, isn't it? Yes. Right, let's take these. So when I was 18 years old, my mama told me, get yourself a job and you'll be happy. Actually, what she said was, get yourself a nice safe job, not like what your father done. And now this goes from pin 7 to, oh, that's a very short span. Oh yeah, I've bent that all wrong. I need to bend that a lot tighter. So yeah, this one's going from output of the first op amp, which on the upper side is pin 7, and to this sort of input node on the second op amp, which sits just in front of the chip. I've got a sort of extra pad there for the input node, and it's 24K. Let's do it. I need the soldering iron. Right, I've just remembered I took all my lithium power tool batteries down to the storage unit before our holiday, and so I've only got these NICADs, which well, they may not last very long, but we'll give it a try. Let's warm this iron up. Oh, that's saying 17.5 volts. That isn't a lot, is it? Right, let's power that on and let that warm up. It's very warm today, so that should help. So yeah, Mum said get yourself a nice safe job, go to Smith's Industries. We lived in Cheltenham back then, and Smith's Industries was in Bishop's Cleeve, or had a department in Bishop's Cleeve. Actually, it was a huge site. And Smith's Industries, aerospace and defence systems company, of course, made avionics, so aviation instruments. I think Smith's originally made vehicle instrumentation, so clocks and speedometers and that sort of thing. And then, of course, they got into avionics, sort of instrumentation for aeroplanes. And then, of course, they got into weapon systems. And I was kind of into the avionics, but the weapon systems, I wasn't so keen on that. Right, this iron is simply not going to run on these NICADs because the voltage is dropping so low, this thing just keeps rebooting. So I think what I'm going to do is take my 12 volt solar, plug it into this boost converter. Actually, I should be able to plug it in directly there. Not put 80 volts through it, so I need to turn that down and step it up to about 20 volts. Let's wind the voltage down there. Oh no, that's the current. Let's wind the voltage down to about 20 volts. Oh, there's no load on the output, so of course the capacitors are going to drain quite slowly. I'll set that to 20 volts, and then I'll put that connector on there, and I can drive the iron. Right, 21.6 volts. So let's plug the iron into that. Switch that on. That should work fine. Oh, that's pulled down a bit. Probably because I haven't set the current limit high enough. I can raise that a bit. That's fine. So yes, I went to Smith's Industries. I got a job there as an apprentice, and my first job there actually was test software. I wrote some test software to test things like, I don't know, auto throttles and other aviation type devices. And I wrote the software in a language called Atlas. I mean, it's probably archaic now. And what it did is it talked to various pieces of instrumentation like voltmeters, ammeters, but also power supplies. So you instruct power supplies to put various voltages on various test points, and then you'd instruct voltmeters to measure those voltages and so on, and frequency meters and all that sort of stuff. And it all used the IEEE 488 bus, I think it was, which is also pretty archaic. So let's clip these leads from that resistor. Yeah, so I think I did a year at Smith's Industries, and then they put me on a, well, it wasn't quite university, it was a polytechnic, a course, and it was, I think it was the first year of a brand new course called Computing and Control Systems. I got one resistor on there, and I went off to do that, I think, for a year. Yeah, that was it. Right, I need my 68 nanofarad capacitors now, 4 of them. I've got 5. So I'm going to model this on filter 4, so my spans are 2 holes and 3 holes. Let's get some of these capacitors in. 683, that looks about right. So the first one goes to the input node, or from the input node to pin 6. That's the span of 3. The other one goes from the input node to pin 7. That's the span of 2. Now that's actually, neither of them fit particularly well, so I'm just going to have to push them down as far as I can go without stressing the wire against the sort of brittle coating of these capacitors. Right, lots of blue tack to hold those approximately in place. They're slightly off the board because I can't push them fully down because they just don't sit there. So let's solder those. So yeah, I didn't get on terribly well with college in the second year. The first year was fine. I breezed through it really. The second year I really was a bit distracted from study. Thing is, you see, my mum told me to go to Smith's Industries, and Smith's Industries told me to go to university, or Polytechnic as it was then. And neither of those things were my choice really, and so I kind of didn't focus very well on it, and didn't do very well in my exams after the second year, and got booted out of college, which didn't go down terribly well with Smith's Industries because they were paying for it, I suppose. Actually, no, I got a government grant because in those days, university, you got a government grant, but Smith's kind of supplemented a little bit. We got, I don't know, what's it called, bursaries or something. And so I was kind of hauled up into the department manager's office, and he said, right, you've got two choices. You can either be sacked or you can go to the local Cheltenham Technical College and do an HNC. So I said, well, I'll do that then, because I didn't really want to be sacked. So yeah, I went to the local technical college. I think it was Gloucester College of Art and Technology. And I did an HNC just in basic electrical and electronic engineering. And that was day release. That wasn't a block release. That wasn't full-time education. That was 1 day a week. And I was just so much better at that. And I got fantastic grades. It was just literally the way I wanted to study. I didn't want to study intensively. I wanted to study occasionally, I suppose. Right, we need the other two capacitors, 683, 68 nanofarads. Again, that goes from pin 6 to the input node for that one. And this one is pin 7 to the input node on that one. I'll show you what I mean by the input node actually. This is the input node. It doesn't connect directly to any of the chip's pins, so it's kind of just a node all on its own, but it's got resistor, capacitor, 4 components connected to that node. So that's what I mean by the input node. Right, time to solder these. The iron's still on. Oh, it's gone into sleep, but it'll soon get back to 350. That's fine. So yeah, I did my HNC. I got that, although I never collected my record of it. So I've never had a record of getting the HNC, and in fact in all subsequent jobs no one ever asked for it, so I'd never had to show it. I don't even know whether I could get it now. I don't know what records were like at the time and whether it's sort of all online now, but it hardly matters now really, does it? Then they said, okay, well now you've done the HNC, why don't you do an HND, Higher National Diploma? HNC is Higher National Certificate. And I sort of said, well, okay, if I must. You see, once again, it wasn't really my decision to do all this stuff. I didn't make any decisions really about the course of my life back at that point. They were all made for me, and I don't know, I suppose I resented that a little bit. But anyway, I got into the HND, started the course, did about 3 months, and then... Right, this sort of front end resistor, this very first resistor on my filter, which has been 6.2K for all of the filters apart from 2 and 13. It's a 2K for filter 2, so I need to find myself a 2K resistor. Right, here it is, 2K0. What colour's that? Red, black, brown. Red, black, brown. 200 multiplied by 10 to the power 1. Yeah, that's 2K. 2K, excellent. So just to cross-check, filter 13 also has that 2K resistor, so that's there, that looks the same. So yeah, I think this is correct. I need to bend this so that it spans a 1/10 of an inch pitch. That should do. And so yeah, this was sort of the first time I was making my own decisions. So I applied for that job, and it was with Linotype, who did printing. Well, it wasn't quite printing, it was pre-press. It was the setting of the images onto films. which would then be used to make the plates, which would go on the presses. But at the time, Linotype only did the pre-press stuff. So it was all image setting, it was all laser imaging technology. I mean, it was very interesting stuff. But I wasn't particularly interested in print, but I just thought, okay, well, it doesn't matter what it is, as long as there's some electronics to do. And I get my company car, so no longer would I have any car expenses. That would be a fantastic job. So I went along for the interview there. And of course, it all got messy. I went for the interview. That seemed to go quite well. I was waiting for the results of that. Smiths Industries says, we're putting you on a training course. You're going to go off to this. I can't remember whether it was out of the country. I don't think it was. I think it was within the country. But I went off to a training course. I probably should have said to them, look, I've applied for this other job. Don't spend money on a training course for me. But you don't, do you? Because you just don't want to, you don't know whether you're going to get this other job. So I kind of went on that training course. Then I got the job with Linotype. And then Smiths Industries, when I resigned, they said, well, that's not a very good thing to do, is it? Because we've just put you on this training course, which is effectively wasted because you've now resigned. But, I was young. I didn't know what to do. I was just being pushed from pillar to post. So I just kind of went with my gut feeling. Right, let's do this 180K. No, I don't think it is 180K on this filter. It's 180K on a lot of them, but this one, no, it's 82K. So I need to find that. This goes from pin 2 to 1, but I'm working on the top end of the chip, so it's going to be pin 6 to 7. 82K, let's go and get one. 82K, let's have one out of there. Oh, there's one on its own. Is that 82? Yeah, grey, red, that's got to be 82K. Right, 82, black, red, so that's 3 zeros, so that's 82K. That goes between pins 7 and 6 on the first op amp. Where did I put it on that one? Yeah, right on that outside edge. So that will go there. Have I got a sort of consistent direction for mounting these things? Yeah, it is that way round, so I'll put it that way. Well, it doesn't really matter, of course, but just to try and keep things nice and neat. Yeah. Now, the thing I didn't know about the Linotype job, they said, by the way, this job's not in Cheltenham. Linotype had their main headquarters in Cheltenham, but they also had a satellite branch in Wembley. They said, this job's not in Cheltenham, it's in Wembley. And I went, yeah, that's fine, I'll just go to London. And so that's how I ended up sort of heading out this way. And I went to Wembley, started that job, which I adored. Company car. No manager breathing down your neck. You just drove off to a customer and fixed their machine. And I seem to be pretty good at fixing machines. I just sort of had this ability to diagnose faults and find faults and do a fix. And also manage the customer's panic, because a lot of customers was panicking because they were losing money because the machine wasn't working. I didn't really have a problem with that. I just sort of got my head down, got on with the job, got the machine fixed, and everyone was happy. Right, there's a low value resistor which goes from the input node of the second op amp to ground, and I think this is the one used for fine-tuning the frequency of the second stage, because the first and the second stages actually have different frequencies, and that's what gives rise to these filter characteristic double tops, because they have, what are they called? Staggered tuning, I think it's called, where the frequency here isn't quite the same as the frequency here, so you get two frequency centers, resonant frequencies, I suppose it is. Right, so what have we got? That resistor is different in every filter case, I think. What's it called? It's called R4. Oh yeah, they're all different. This one is 910 ohms. Oh, I don't think I've used one of those before. Have I got one? Yes, I have. Look, 910R. There are 10 of them in here. This was one of the packs. It was a sort of monster pack of various different values. Actually, it wasn't that monster, really, which came from Rapid Electronics. That kind of got me most of the values I needed for this vocoder project, and then I had to top it up with a few eBay purchases and a few packs of 100 of various strange values, also from Rapid. Anyway, 910 ohms. So 910 ohms starts with white. White, brown, black, black. That looks like the one. 910 ohms. That's a really strange one. Not familiar with that colour scheme at all. So I did the first 2 years at Linotype, which was at Wembley, and then it moved to Brentford on the A4, near where all the Sky TV buildings are now. Opposite side of the road, actually. They were like a honeymoon period. They felt like I wasn't even working. It just felt like I was earning money, driving around in a company car, and the whole thing was just a lot of fun. Of course, in any job that wears off, and you don't think like you're earning money for doing nothing for too long. And then after 2 years, an opportunity came up in the technical support department, which they called FETS, I think it was, Field Engineering Technical Support. And it was more money and sort of a higher, or kudos, I suppose, status. And so I applied for it. But of course, that meant that I got stuck in the office for 5 years. I quite enjoyed it for a while, but then it started to get a bit, because, you know, you've got your boss there sitting in his office, breathing down your neck. It wasn't quite the same as being out on the road. That was always nicer and easier, and you know, if you finished a call at like 3:30 in the afternoon and you called in, you say, is there any more work? And they'd just say, no, go home. It was nice being out on the road. Right, so let's bend that at the white band, the 9. Oh, I need that slightly fatter actually, because this is going to sit across a diagonal. It goes from the input node of the second op amp, this one, to ground. So I think on the previous filters I've shoved it in at an angle like that. 910 ohms. Yes, that looks fine. Let's solder that. Then I sort of left the technical support department and went back out on the road again. And there was a customer in London, near Old Street Roundabout, actually, in what's Shoreditch, I suppose, Hoxton, that area. And they were very impressed with a visit I did once. They had funny Japanese fonts. They did a lot of Asian typesetting, image setting. And of course, nobody knew how to install Japanese fonts because not many customers used them. And I had a problem where it kept saying disk full, and it clearly wasn't full. And I had this kind of thought. I thought, maybe I've got some sort of funny bit overflow thing. And if I fill the disk with just loads of rubbish and get it just over half full, maybe I'll get a sort of overflow rounding error type thing, and it won't say the disk's full anymore. And it worked. It was amazing. Actually sticking more stuff on the disk overcame that bug, and they were able to carry on working. And people don't really care how you fix their machine. They just need it fixed because they're losing money. And they were really impressed with that. And he said to me, if you ever want a job with us, come and speak to me and I'll give you a job. And it was a lovely company. It was run by 2 Polish guys, or what was it, Arthur Gachowski, although you pronounce it Gachowski, and Yannick Schlenkier. Yes, that was them. And so a few years later, a couple of years later, when I finally had enough of Linotype, I approached them and I said, is that job still going? And they said, well, not really, but we'll take you on anyway, and we'll just somehow fit you into the company. They were great guys. Right, next I want these 2 resistors, and they're the same value. In most of the filters, they're 220k. What are they in filter 2? Oh, they're 110k, 110, 110. And they're the same value because what you're trying to do here is balance the current going into both inputs, so you don't get a DC biased current offset thing, which is why there's a resistor here from the non-inverting input to ground, but not here, because this one has a DC path through these resistors through lots of these subsequent stages, whereas this one has these 2 capacitors which kind of block DC, so you don't need to be so concerned about eliminating DC offsets here, but you do here. I found a brilliant website actually where this is all really well explained, and I'm going to show that because I've been in touch with the guy who produced that website, Rod Elliott, and it just tells you everything you need to know about this particular circuit. It's amazing. Right, here they are in my sort of collection of weird values. 110k, I need 2 of these. So yeah, I mean, I was at Linotype for 13 years. I mean, it was a good old run. 2 years in field engineering, 5 years in tech support, another 5 years in field engineering, and then I did 6 months back in tech support, but that was a mistake. I wasn't in the mood for it. I then quit the company, went to this company, Direct Image, said, "You offered me a job a while back. Anything going?" And they just said, "Yeah, come in and be our technical support guy." And so I worked in this company in Shoreditch for 3 years it was. Right, one of these resistors goes between pins 6 and 7. Yep, 6 and 7. The other one goes from 5 to ground, so I can find those positions. If I look at this one, they are both 1/10 of an inch apart, so that's 6 and 7, that's 5 to ground. So let's bend them for a 1/10 of an inch span. But Direct Image was quite difficult because it was in Shoreditch. We were living in Hayes at the time, and I was driving to work 1100 and then orange, which is 3, so yeah, that's 110k. Let's bend that over. So it just was hard work driving across London every day to work and back again. And when we moved out to High Wycombe, that became even more difficult, and I think I only managed another 6 months there before I told them I can't do this travelling across London thing. It's just too hard, and it is tough. It's a long way and there's a lot of traffic. There's probably a lot more now. And actually back then I don't think they had the congestion zone back then, so I didn't have any problems with the congestion zone. But I mean, that was looming, and I was thinking, oh, this is just going to get worse and worse and worse. And so I just resigned. Right, my resistors are in, and they're just sort of bent so that they're a bit springy and they're holding themselves in, which I like. Just going to quickly compare that against filter 13, because filter 2 has a lot of the same components as filter 13. I can see that they're 1103, so that's 110k. So that looks good. I'm going to solder those in. So that's a couple of years at Smiths, 13 years at Linotype, 3 years at Direct Image. That's a fair old time span. Then I found myself at a bit of a loose end, but I had received a small inheritance at that point because my mother passed away. So I set up my own company, which was, like most people who set up their own company, a total disaster. Just ended up spending that inheritance. And then a friend kind of bailed me out. So let's solder these. Yeah, so I knew this chap Mark for many years, and he was running a company doing sort of graphic design and various other things, and he just said, come and work for me. There's plenty of work, there's plenty of and we did kind of exhibitions, and a lot of that was quite physical, you know, sort of taking stuff onto site, setting it all up, and it kind of worked having 2 people. So I worked for him for, I think, about 6 years. It was quite a long time. Right, let's just crop these wires off, and I'm just loading the first few shots of this video into Windows Movie Maker because I've been having some trouble with the camera, the phone, this Nexus 4, creating dud shots. And so every now and again there's a shot that just doesn't function and it's missing from the video, and that kind of creates continuity problems. But no, that looks good. All the shots seem to have gone in and they seem to be working, so hopefully things are behaving themselves today. So that, I think, is most of it done. Yeah, here on this one I've put a pair of turn pin sockets in there so that I can actually jumper that resistor out, because on some of the channels the designer of this project used JFET input op amps here, and where he does that, this resistor is not really needed because you don't need to balance the DC bias offsets because there really isn't any on the JFET input. So for those ones he's specified a wire link instead of the resistor, and a TL082 instead of 1458, which is a dual 741. But I think at the time that this project was designed, these JFET input op amps were quite expensive, so he didn't put them in all positions. But I probably could put them in all positions now because the price differential is nothing. Everything's like 20 for 99 cents. So I'm certainly going to give myself the option of wire linking across this second resistor if I use a JFET input op amp in this position here. So I'll probably put those turn pin sockets in there so I can wire link out that resistor, just short it out basically. So I'll see if I can find some of these turn pinned arrays. So yeah, then I worked for my mate Mark for about 6 years, as I say. And during that time, I can't remember when it started. It was 2007 actually, because that's when I registered with YouTube. I started putting videos on YouTube, mainly about the solar charge controller at the beginning, really to promote its sales. But then the videos just started to gain momentum, and really it kind of crossed over as the work that he was able to give me was tailing off, and I kind of could only do 4 days a week. The income from YouTube was kind of ramping up, and it just kind of timed itself almost exactly right. And there came a point where he really didn't have the means to carry on paying me, but YouTube was kind of getting quite good. So let's break some of these little turned pin arrays. I need some triples, which I'm using here to distribute positive 12 volts and negative 12 volts from each module to the next module so that they're all powered. So I need a couple of those triples. There's a double there for the input signal. There's a double there for ground. So I'll do a couple of doubles. So yeah, I hope that answers your question, Gainster. What did I do for a living? I had probably about 4 different jobs. I tended to stick at jobs for a reasonable amount of time, probably because I just don't like change much, so I kind of didn't change things very often. But yeah, the longest job was linotype, and that was 13 years. Right, just solder these turned pin arrays onto this, which I believe is the positive 12 volt line. Just come around there to get that nicely done. I'll solder the rest of those in, and then that's pretty much all I'm going to do for this. And that gives me 12 filters, and I'm going to put one of these little VU meters, these little 5 LED VU meters on every one of the 12 filters. And so I should be able to power up a 12 channel spectrum analyzer once I've done that. Now, I was going to show you this, wasn't I? This is a page on Elliott Sound Products website, and it's specifically about the multiple feedback bandpass filter. And that's exactly what I've got. I've got 2 of these MFB filters, one immediately following the other. And this page was just a massive help to me to make sense of these filters, to understand all about Q factor, the components involved in setting the frequency, even this staggered tuning arrangement. So I wrote to Rod and I said, can I show this? And Rod's been very kind enough to say, yes, you can. So that's fine. And you can see here that he says these filters are useful for equalization analysis and other tasks such as the sound to light converter, which is his project 62, or even a fully functional vocoder, which is of course what I'm building. And his article here also answered the question I had in a previous video about why do we need a resistor from the non-inverting input to ground? And he answers it here. He says a resistance from the positive input of the op-amp is optional to minimize the DC offset voltage. In general, this is completely unnecessary because the filters are not DC coupled anyway. Maintaining DC accuracy serves no purpose and is actually impossible. However, if you use the resistor from positive input to ground, it should be the same value as R3, which is the negative feedback resistor across there. And so that's why those resistors exist in the vocoder circuit that I'm building. But this just explained it all. It was really the perfect article. I couldn't have come across a better article to answer all my questions. So most definitely I'm going to put a link to this in the description below, so that if you're interested in these filters, you can come and have a read of this article. And thanks very much to Rod for letting me show this. So that's really it for this video. I'm just going to solder the remaining turned pin sockets onto here so that I can connect all these boards together. Oh, that was supposed to be stuck down on blue tack and it's moved. Yeah, so the next video really on the vocoder will be me attempting to use these 7 boards to make a 12-channel spectrum analyzer, and I'm probably going to whistle into a microphone again, like what I did before. Anyway, for the moment, I think that's it. So, cheerio.